Okay, here we have a 1950s Sunbeam engine block, and what we're going to do here is we're going to machine out these bores here to the next size up there. I still have to confirm with my friend exactly what size we're going to make this here, but they're all imperial sizes. There's a couple of formulas we have to sort of deal with here to make this all work. We're going to use a cutter like this one here. This one here, it's a boring bar that we can adjust here. There's a little nut here, you can adjust the sizes here. So we're going to use that for the adjustment here. And we're going to use the Haas machining centre, this particular machine here, to do this work. We've made up a little program that should run this here. I'll take you through that as well, but the program in at the moment is loaded here, and I'll just explain to you how this is going to work in another section here. But that's the project at the moment, and we're going to machine these bores out to the next size up for the oversized pistons. Okay, so we've set this up in the machine here. We've got some clamps over here on the left hand side. We've got a little bit of wood underneath here to protect the bore here, and we're doing the same thing on the other side here. And we're not bothering squaring this thing up, because what we'll do is we'll just clock the first bore here, and we'll just find it, we'll zero that, that'll be our G54 position here, and we'll just find our other position there and just program this directly to the program there, so we don't have to bother squaring this up. Okay, so what we've done now is we've clocked up this particular hole here and zero set that, and then we come along here, we've clocked up this particular diameter hole here, and now we have a position over on our screen over here of, we have these particular sizes here. So what we're going to do in our second hole here, we're going to program those sizes in here, so when we do our shift over, we can put those sizes directly on the machine here, and that way we'll bore the two holes together.
The program I have up at the moment is called NC-Plot. It's what we call a backplotting program that reads over here, reads the just the text code that goes into a CNC machine, and it gives a visual sort of image of what the machine's actually doing. So if we put in our text over here, we'll get our text. It's just I've just got a Word document text here. In fact, it's the rough draft of the blog that I'm putting up anyway. So I just put this program on the end of it, and you can click this and cut and paste this directly from the blog itself if you like. All you do is highlight the text, right click, go copy, back to NC-Plot, right click and paste. Now NC-Plot, I'll just update that, there, yeah, okay. NC-Plot, you can access this on the net. You get I think a 15-day free trial, and I think you have to pay something for that afterwards. I think it's around about $250 or something like that. But it reads text, it reads the code the machine reads, and so whatever you write in here, basically it will read over here. Now we'll just go back a little bit. I think we can zoom back, and we'll zoom back a little bit. The machine itself, let's explain the program a little bit. All programs start off with a percentage, top and bottom here. So you see the percentage sign there and a percentage there. We always have a program number, and that's the letter O with the number of the program in here, in which case it's O2222. We normally turn a few things off with this code here. There's a cutter compensation cancel here, which is the G40, and the can cycle cancel, which is a G80. And it's normal to just run it through this here, just in case there's something on from a previous program that is going to cause an issue. So we'll just make sure everything's turned off before we turn a few things on. The G91 is absolute position, incremental position, which runs from a point from wherever it is to somewhere else, rather than the G90, which is always from the X and Y0 position, which is that point there. So from wherever it is, we want to send it home to the machine home position, it's the G28 code there, to Z. So we're only sending the thing home in Z, we're not doing the X and Y. We're using the G54 coordinate position, and we've put our block up on our engine block up on the machine, and we've clocked up our first hole, which is that point there, and we're calling that our G54 position. So that position there is recorded in the machine. We're using tool number 1, and we're making sure the tool change of tool number 1 is executed, which is MO6. Then we'll go to G90, which is absolute position. So now we'll be at the absolute position of the X and Y0 of the G54. And we're going in rapid, which is G00 to X0, Y0. So we're at that point there. Now we're still up here somewhere on our machine, and we're going to come down here 10 mil above the job, and stop here 10 mil above the job, and we're using this height. The G43 is the height offset of the tool, which is programmed into the machine, and we're calling it the height offset of number 1, which is the tool number. We're stopping 10 mil above the job, we're turning our spindle on at 150 RPM, and our feed rate is 25 millimeters per minute, and MO3 is clockwise. So we're rotating the spindle clockwise around here as it bores this hole. Then from there we're going to what we call a can cycle, which is G76. Now there's also G70. There's a whole bunch of what we call can cycles, and this one here is a boring cycle. So what it does is it starts the spindle up at 10 mil above the job, bores down to the bottom of 130 millimeters, that's what that is there, and then stops the spindle, and then rapid retracts back up. And of course, if you give it another coordinate, whatever coordinate you'll give it, it will just repeat the G76 over and over again until, of course, you see a G80, which turns off the G76. So you'll see here we've got the coordinates for the other hole here, X negative 96, so we're going 96.72 from the original hole position that way. And because we just bolted our job down straight to the table and didn't worry about squareness, we just clocked the other hole here, and it just so happened that this was 0.34 out of position from the Y0 there. We'll go up to the top here, we'll view it, the XY straight down the top of the machine here. You'll see here that that's slightly out here, and of course if I'd remove that there and make that just 0, we'll update that there. That will move back in here perfectly in line. We'll just undo that and just redo that again. So now we sit in the position there. We'll go back into the pictorial view here, and I'll just give you an example of what happens if I put another coordinate position in. Let's just go Y50 decimal point and update that. It will do bore another hole 50 mil over. And of course we're not doing that, we're just doing the two holes here. And of course then we come along, we've bored our two holes here. We'll just update that. And then we'll see the G80 there, the G40, which is just the standard thing we had up the top here, but that G80 there will cancel this G76. And of course when we're finished, we're going back up to the home position, which is on our job here, about here somewhere, way above the job here, which is our Z home position. M30 just rewinds the program, so as soon as it sees the M30 it will go back up to the top here, and if you just press the cycle start the machine again, it will repeat the entire program.
Okay, we're boring away again. We're taking a 0.1 cut. Okay, that's finished. It'll be up in a sec.
Part of the piston will wear quite, fast enough, and then you've got all that clearance behind it down below. Yeah. It goes to 70.6. So it's actually, what, 2 thou smaller there. So when that wears there, we'll get plenty of clearance.
Right, okay. Now let's take some sizes here. So we're going to measure these sizes here. Now one board will be the same as the other. Now that's actually quite a coarse finish. Feel that? That's a very coarse finish. We need to feed it slower.
Yeah, we've got it.
We'll take a size. Close it up there. Okay, run up here. So we've got 70.25. We've got to get a 70.7, so there's 0.1, 0.2, 0.3, 0.45. 0.45 mil to bring it out to 70.7. So, how much more are we going to go?
Oh, look,
We'll do another... we went 4 divisions, didn't we?
Yeah, five divisions.
5 divisions.
Yeah.
So we go how much more? Another 5?
Well, we'll take, well, we can take 0.1 off, can't we, really?
Yeah, so we go 10.
Yeah.
There's heaps to go.
Oh, well, we're only at 70, aren't we? Shoot.
Yeah, I know, we've got miles to go. Let's take 10 divisions.
Yeah, 10 divisions we'll take.
Okay, we think we're about right now, so we're just going to check these sizes here. We're at our telescopic gauge. Open out there. Put it on a bit of an angle. We'll tighten this up. Put this back in here. Now at the moment the telescopic gauge is too big. We'll just keep pushing that through here like that, all the way through there, and that goes free. Now back over here on the bench. We've got here, we're on the 07. So we've got 70.71 millimetres there, and on our piston we've got around about, something like around about that there. So we've got about 05 clearance at the moment, and we've got to go a little bit bigger because we've got to hone this out down the track. So we'll probably end up at around about here when we're finished, by the time we've honed it, around about there somewhere. Okay, and that'll be the correct size for the piston. And we're just going to remove this job. We'll take this out of the machine now, and we've got to give that a hone there. So it's pretty much, we'll just get Jamie to do the honours here. Okay, that's a wrap.